So the double chain rule. You'll have just like an extra level of it. So we talked about like a big guy and like a Mr. Packard. This would be like a big guy and then Mr. Packard and then Jack. Mr. Packard's kid. One Mr. Packard's kid. So there'd be like there's a big, a middle, and a little, if you want to think of it that way. And you do the same process, you just do it twice. So I'm just going to start doing examples. There's not a whole lot of explanation I need to do. So let's say something like this. So the first thing to realize is this fourth power really applies to the whole thing. And it's way easier to see that if you rewrite it as cos of 2x all to the fourth. Those are the exact same thing. But in this second version here, I think it's a lot easier to tell what the like outside dominant big guy is. So what's the biggest guy here? 4. What's the middle? The cos. And the little guy is 2x. So we're going to take the derivative of the 4. We're going to leave the next two the same. And then we just move down the line. Then we take the derivative of the cos. We leave the 2x alone. So the 2x will get left alone twice. And then finally we get to the derivative of the 2x. So the derivative of the outside power, or the outside dominant function is a 4. It's a power. So the way we take the derivative of that is to bring it down, reduce by 1. What do we do with everything that I haven't taken the derivative of yet? We leave it alone. So I can almost go up here and like cross off the 4. I've already done that level. And I just move to the next biggest. So the next biggest is cos of 2x. What's the derivative of cos? Negative sign. What do I do with anything I haven't taken the derivative of yet? Leave it. So that 2x gets left alone again. And now I've done the cos. And then I take the derivative of the 2x. You could look at this a little different too. You could think of it as just like it's just chain rule once. And then you end up within the chain rule doing chain rule again. So some people will go, okay, let me just do it again. I'm going to do the 4, I'm going to leave the little guy alone, reduce the power by 1. And then the little guy is cos 2x. Instead of like a big and middle little, you could just say the little guy is cos 2x. Take the derivative of cos 2x. But then doesn't cos 2x have its own chain rule? So you can, I mean, it's the same thing, just maybe a slightly different thought process. Then I would go, okay, now I'm going to do cos 2x, which is negative sign, leave the little guy alone, and multiply. And then an AP test would probably make this like negative 8 cosine 2x to the third times negative sine 2x. But I'm fairly certain you could realize that 4 times negative times 2 is negative 8. I'm not worried about the simplifying part right now, just getting the derivatives. What? Oh yeah. Question on that? What? Alright, let's try e to the tan of 3x squared. So what's the big guy? E, then what's next? Tan, and then 3x squared. So go ahead and take a second try. So what's the derivative of e to the whatever? E to the whatever. So like I have just taken the derivative of the big guy right there. Even though it doesn't look like I changed anything, that's how e to the x works. And then I move on to the next level. So the derivative of tan is secant squared, and I leave that 3x again, and then finally I multiply by the 6x. How many had that? Thanks. Questions? Yeah.
Do I need the quotation or the parentheses?
Around the 3x squared? No.
Okay.
I think it makes it way easier to read, but you don't need them.
I'm just making sure it's not wrong if I.
It is not.
Good.
Try that. I don't think it's that bad once you start doing it, but it looks like it just looks weird. People get intimidated. So the big guy is this ln. The next level down is this ln, and then just the x. So the derivative of ln of blah is 1 over the blah. Times, and then go down to this next level. What's the derivative of ln of x? 1 over x. Times, and then go down to this level. What's the derivative of the x? 1. So I don't even need anything there. But if this was like 6x or something, you'd have something else there. And so this just becomes 1 over x times L of x. How many of that? Question on it?
Do we need to simplify everything? Oh, I mean like simplify it down to x times 1 over x times L of x.
Like you just left it like this, you mean?
Yeah.
That's okay. Multiple choice, they'd probably do that, but I think you can realize that they're the same, you know? Let's say ln of the third root of 4x squared minus 1. No negative exponents allowed in your answer. I would rewrite it for, I'm not doing it yet, I'm just giving a hint to people that haven't started yet. I would rewrite it first. So you're done with that radical sign there. And then your big guy's the ln. Your middle level will be the 1/3. And then the 4x squared minus 1. So I'm going to work my way biggest to smallest. So the derivative of ln of something is 1 over the something. And then I get to the next level, so the 1/3 is the next power, so bring the 1/3 down, leave that 4x squared minus 1 again, and reduce the power by 1. And then multiply by the derivative of the 4x squared minus 1. So this is the derivative of the ln, this is the derivative of the 1/3, and this is the derivative of the 4x squared minus 1. And then I got some work to do to simplify this stuff. Wait, this should be to the 1/3 here. So I got a fraction kind of pre-established where this is on the bottom already. This 3 is on the bottom. And then these 1s are both on top, and I don't really have to put a 1 on top. This 8x goes where? On the top. And then this goes down and becomes a positive exponent now. So you're welcome to leave it like that, but how many 4x squared minus 1s do I really have on the bottom now? I have 1, right? I had 1/3. I put 2/3 more down there. When you're doing powers, when you multiply bases, you add up the powers. So that's the answer that AP does give you a multiple choice. If it were a free response, I'm okay with this. How many had that one? That's a little tougher. Questions on it? I don't see why you did this. How'd you get from here to here? Help. What the F of X is going on here? Alright. Let's say, kind of like look at your worksheet and give you similar examples to some of the tougher ones. The square root of sec of x over 3. Again, I would rewrite it first. Make it like sec of, I would probably write it as sec of 1/3 x. So the 1/2, because that just looks a lot easier. That x over 3 messes people up, like the x over 2 on the warm up we did. So I think it's a little easier if you separate it to 1/3 x so you can see the coefficient easier. You don't have to, but just a thought. And then no negative exponents, right? So the big guy is the half, and then the sec, and then the 1/3 x. So the big guy's a power. The way I take the derivative of powers, bring them down, reduce the power by 1, leave everything else alone. Then move on to your next level, which is sec. So what's the derivative of sec? Sec tan. I leave that 1/3 x alone again. And then the derivative of 1/3 x is 1/3. So getting rid of negative exponents, putting those all in one fraction this 2 and this 3, I'm just going to make a 6 on the bottom. This has a negative exponent, so I'm going to put it on the bottom. So that's to the 1/2. And then on top, I have sec of 1/3 x, tan of 1/3 x. Now that's a perfectly acceptable answer. The AP test would do this. So what did I do there?
Keep changing the,
No?
oh, you switched, you got rid of the seek on the bottom.
How or why? I have one of those up there, right? And a half of those down there. So what do you do with powers when you're dividing? You subtract. So 1 up there and then a half down there is really the same as just a half up top. And again, on a free response, leave it here. There's no benefit to going on. You only have possible to lose. But on a multiple choice, you would need to be able to match up. That's what they did. Questions on that one? How many had either one of those answers? Okay. Let's see what else. This is, I believe, a triple. 1, 2. Yeah, that's a triple. This is 3 chains. It's going to be 2 chains next album. 3 chains. And then, with this stuff, find the slope at a point, find the equation of the tangent line, find the equation of the normal line, find the horizontal tangent line. So all that stuff just keeps carrying through. We just learn new ways to take derivatives. Before I do this problem, I want to talk about the gateway for a second. But I want to just remind me, because not everyone's done this problem yet. Gateway, gateway, gateway. You guys play it? Play any good? Are you guys any good? What's your top half of the league? You're what?
Yeah, I think we're top below SMCC,
Which is like always,
below
right?
airport right now, and below Flower.
Okay.
But I think we can beat airport.
But you're decent.
We should win 2. We beat them already.
Okay.
And we've got a really good draw for our district. We play Dundee, and they're not very good.
And then, who's like the toughest team with your district? Who's on the other side? Are they good?
Ida's really good. We lost to them last
They're always good at girls' sports.
year.
Okay. So, gateway, before I forget. So, we kind of got 2 things going on as I'm teaching all this stuff. There's one that's like the concepts and how do you use it. That's like the horizontal tangent line, equation of the tangent line, equation of the normal line, find the slope, that kind of there will be more of those concepts. That stuff will carry through until we have a giant unit test on all of the derivatives. Before that, there's going to be what's called a gate, what I call a gateway, where it's straight up, can you take the derivative of these 10 things? And I got this idea from when I was at U of M. You took Calc 115, it was like the intro calc class. But you also had this gateway that they were like, you have to go take this gateway. You can take it whenever you want. Go to this building. Tell them you're here for the Calc 115 gateway. If you pass it, you are done. If you don't pass it, you don't get a grade in the class until you pass it. So like you would fail the entire class if you couldn't pass this 10 question derivative thing. I'm not going to do that. That's crazy to do in high school. I'm not going to do that here. But I try to do something similar. So I'll give you a 10 question, just take the derivative of these 10 things, and it'll be worth 100 points, and there's no partial credit. So if you have, if you screwed this one up, the one I just did back here, I had like an extra negative sign on one of these, on this one, I would mark that wrong. I'd say you got it wrong, now you got 9 out of 10. But to make up for that, I give you 3 attempts, and I'll take your best score. So 10 questions, take the derivative, there's nothing else, there's no concepts, there's no other thing to it. Any mistake is a wrong answer, because that's how the AP test would work. But you do get 3 tries. So that's where we're headed. So be careful about checking all these and make sure, because it's really easy. And I do it too. That's no big deal, I forgot a negative sign. Well, it is, you got it wrong, that does matter. I think it's easy to explain away little errors. I'm just trying to force you to be really careful with that. So that's where that'll be in probably 2 weeks or so, and then more concepts and stuff, and then we'll do the bigger test on all of the derivatives. Make sense? Okay. Why are you laughing and smiling? You get 100% of the first one. Don't take the other 2. Okay. So what's the biggest level here? E and then a half and then cos and then 5x. So the derivative of E, so the whatever is E, so the whatever. Then the next level is a half. The way you check the derivative of powers is bring them down, reduce by 1, leave the inside alone. The next level is cos. What's the derivative of cos? Negative sign. The next level is 5x. Derivative of 5x is 5. Some people take this a step too far, and they'll take the derivative of the 5 now, which will give you 0, which make your whole answer 0, right? But there was not a 5 wasn't one of the original levels. So don't just keep going until there's just nothing left. Don't go past anything in the original problem. All right, now I got some simplifying to do. So this 1/2 and this 5 and this negative, I'm going to go negative 5 over 2. So I've used the 1/2, I've used the negative, I've used the 5. And then anything with a positive exponent stays on top. So the e to the cos 5x to the 1/2 and the sine of 5x. And then on the bottom, you got the cosine of 5x to the 1/2.
Can you keep the negative on the sign?
Yes, this negative could be really in any one spot anywhere. It just can't be in 2 spots, because that would be positive. You could put it in 3 spots, 5 spots, 7 spots. How many had that answer? Questions? Okay. Those are cool, aren't they? I like them.
Yeah.
That's not
I was saying, what you said, after you got that, everybody raised their hand, and then anybody have any questions, everybody lowered their hand.
Oh, okay. I got you.
That was cool.
try?
Let's try.
Just 8.